AI systems don't just make mistakes. They make different kinds of mistakes. And understanding the difference between those mistakes can be the difference between trusting an AI system and being surprised by its decisions. Hi, I'm Bob, and I work with Dan. Between us, we spent over a decade delivering technology solutions as software developers and technical leads. And now, we're helping businesses use that same technical thinking to get real advantage from AI. In this video, I will talk about false positives and false negatives in AI systems. What do they mean? Why they matter? And how to think about them when you are using AI in your business. Let's start by clarifying what we actually mean by positive and negative, because this often causes confusion. In AI and statistics, positive doesn't really mean good, and negative doesn't mean bad. A positive simply means the system believes something is present, and a negative means it believes something is not present. A false positive happens when AI predicts something is present, but in reality it isn't. A false negative happens when AI predicts something is non-existent, but in reality it is. Let me show you a few examples. Imagine an AI system that detects fraudulent transactions. A false positive would be a legitimate transaction being flagged as fraud. A false negative would be a fraudulent transaction slipping through undetected. Or consider an AI system that monitors manufacturing quality. A false positive would be flagging a perfectly good product as defective. A false negative would be allowing a faulty product to reach customers. Now, why does this matter? Because false positives and false negatives have very different consequences. False positives usually create friction. They waste time, trigger unnecessary reviews, or interrupt normal workflows. Someone has to investigate a problem that actually doesn't exist. False negatives, however, are often more serious. It means the system fails to catch something important. Fraud goes unnoticed. Faulty products reach customers. Risks remain hidden. But here is the point. Neither is always worse by default. Which one matters more depends entirely on the use case, and there is often a trade-off. For example, in medical screening, false negatives are usually far worse. Failing to detect real illness can have serious consequences, so systems are often designed to accept more false positives, even if that means additional tests or follow-up checks. In customer-facing systems like content moderation or spam filtering, false positives can be more annoying. Incorrectly blocking legitimate users or content can quickly erode trust and make the system feel unreliable, even if it reduces the number of genuinely bad cases. As you can see, too many false positives increase operational costs and frustrate customers. Too many false negatives lead to hidden risks. Whichever is worse depends on factors like cost, risk tolerance, user experience, and how easily mistakes can be rectified. So when you are using AI, the real question isn't how to make the system totally error-free, as predictions always come with some probability of being wrong. The real question is how to design the system to reduce the error rate and the impact from unintended consequences. This leads us to how false positives and false negatives can actually be tackled in an AI system. The simplest and most common approach is adding human review, especially for high-impact decisions. For example, letting AI flag cases while a person makes the final decision when the cost of being wrong is high. In practice, this often works best when the AI also provides a confidence score, so human reviewers only need to look at decisions where the model is less confident. We should also improve the system over time based on real usage. By reviewing real-world decisions, you can identify patterns where the model gets things wrong and feed that information back into the model. This kind of continuous improvement is often more valuable than trying to build a perfect model upfront without seeing the real use cases. Another approach is to use parallel evaluation. That means running multiple models or pipelines in parallel and comparing their outputs. If the models disagree, the case can be flagged for manual review. This approach can significantly reduce risks in systems where accuracy really matters. So false positives and false negatives aren't just technical concepts, they're business decisions. Understanding them helps you make better decisions on how AI can be used in your business. If you found this video useful, please like and subscribe for more videos on how to get real value from AI in your business. If you have any thoughts, please also drop a comment in the comment section below. Thanks for watching. I'm Bob from Dan Bob AI, and see you in the next video.